Subtracting. You can only add or subtract. Yeah, Logan. Quit. Unfreeze it.
Why? We're done.
You might be done, but everybody's not going to move. When you add or subtract, they have to be like radicals. Multiplying and dividing is easy because I can put them under that same radical as long as the root's the same, but I can't add or subtract unless they're like radicals. So let me show you what this means. Let's say I have the cubed root of, say I have 5 times the cubed root of 2 plus 7 times the cubed root of 5 minus 3 times the cubed root of 2. In order to be like radicals, the root and radicand, what's a radicand? What's underneath the radical? The root and the radicand must be the same. And if they are, all I have to do is combine them just like I do with like terms. So which of these are like radicals? The first one and the last one. The roots are the same, the numbers under the radical is the same.
Why didn't I get to go on that field trip today?
So therefore, Charlie. Here's my like radicals. So I combine the number in front, I leave the radical alone. So this becomes 2 cubed root 2. Logan, get out of my desk. Get out of my desk. It's not about you being quiet. It's about you being in my desk.
This is just combining like terms.
That's all you can do. So we're going to combine all these operations, and you're going to have to know what to do when. Let's see. Let's say, for instance, you might have to manipulate these a little bit before they work. Logan, if that screen is frozen, I'm going to write you up. This ain't about what you want.
Okay, you need to pull out.
Simplify. You might have to simplify them and see if you can get them to be like terms. What you got? Anybody get it?
We got.
Oh, sorry. Yay, dang, you ain't gotta be nasty. Charlie got this one.
Well.
What? What's your educated guess? Bruh, you ain't been listening to anything, have you? How about this one?
That would be.
I haven't simplified it yet. This one's going to be 7 times 2 times the 4th root of 3 minus 2 times the 4th root of 3 plus 3 times, how about 72? Is there a perfect third that I can take out? 8. 8 and 9, that's exactly right. Times 2 times the 3rd root of 9. Yeah.
So,
Yeah. That's what you're looking for, a number to that, but yes. Yes. That's correct. That is absolutely correct. Once I have everything completely simplified, by the way, does this simplify cube root of 9? Say no, because it doesn't stop. Logan, go over there because you are distracting everybody in front of you. Nobody can see. Hank's going to be lost because he's been watching his video the whole time. Logan. No, because this is a third root, not a square root. All right, so now I look at which ones are the same, which ones are like radicals. Combine just the numbers in front and leave the root the same. Oh. Multiply into. We're almost done. No, not here. Whenever we're doing whole expressions like this, we won't do the plus or minus. We'll only do that whenever it's just one and we're simplifying it down. I know that gets confusing, but no, because I'm not done. Yeah, but they're quick. They're quick. One more addition. This is with the variables, and then we'll move on to dividing. I mean, multiplying. No. Nope.
Wait, what's the little rat's name? Oh, is that the rat's name? No, that's the name of the food.
Remy, now hush.
Yeah, Remy the rat. Remy, literally Remy the rat. I ain't gonna lie, I know some people that look like the rat.
I'm just looking at my numbers right now, splitting those up first. They're both cube roots, so I'm looking at powers of 3 that I can split this up. I would say -2. And I'm still not even done splitting up because I've got these variables in here also. Logan. How many times does 3 go into 7? 2. What's left? 1. So I got cube root of 5a. How many times 3 go into 4? 1. I've already got 2 out here, so that's going to give me 3 out here. And it leaves me with 1 in here. So while these are like radicals, these in front I can't combine because they're not like terms. You would, yes, yes. So what you could do is you could say -2a squared plus 6a cubed, and then put the cube root of 5a on both of them. But either way.
Literally same thing.
Yeah. All right, let's multiply some and we'll be done. The key to multiplying. If they have the same root, put them under the same radical. This is still that same stinking property we did. If it's like this, I can go backwards and forwards if they're the same root. The root here doesn't, as long as they're the same, I can go backwards and forwards. And then I'll simplify from there. So for example, -3 times the 4th root of 64 times -4th root of 8.
Are you sure?
I'm positive.
Literally?
Positive. What? Can I simplify either one of those before I start? Which one? 64. I could do. Some people don't split up before you start. I always split up before I start. It's a little bit easier. 16 and 4, right? That's a 4. So now I have, this becomes 4 and comes up here, right? So I have -12 times the 4th root of 4 times, oh, it's 2. I'm sorry. Let me go back and start over because you'll confuse you. All right, so this is the 4th root of 16 and the 4th root of 4, right? The 4th root of 16 is 2.
And that's good. Literally.
So now I'm going to multiply everything outside the radicals together and everything inside the radicals I'm going to put together. So I've got a negative times a negative, which would give me a positive. So I end up with 6 times the 4th root of, what's 4 times 8? And now I need to try to simplify again. I know. 16 and 2. So I get 6 times 2 times the 4th root of 2, which is, we won't worry about the plus or minuses right now. We'll just focus on this right now. We'll come back. Because this was negative also, so the two negatives went together and made a positive. Try that one.
Literally, you can't do that.
Okay.
No. I don't think so. Literally, I don't see where it's possible.
You've got 45 minutes to work on them in here.
Yep.
We'll do this when I show you how you can go about it a little bit differently. I can go ahead and combine before trying to simplify that. If you wanted to take an 8 out of that, 8 and 4, you could. Or you could go ahead and put them together 36 times. 8 and, it doesn't work. Sorry.
Yeah, literally.
You are so distracting. What does that give me? 108? Is that right? And now multiply these together. 7 and 6 is, y'all can at least do that. Y'all, you tell me, what do you do? If you're multiplying them, what do you do with the exponents? Add. If I do a to the 7th times a to the 6th, I multiply the bases, or I'm multiplying those two things, so I add the exponents. Now what? Separate it out. That's right. Can anything go into negative 108? That's the power of 3. Okay, so I'm going to think about powers of 3. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. Can I divide this by any of these numbers?
Yes.
What?
No, you literally can't.
4's not on there, though. Oh, 27. I'm sorry.
Huh.
I couldn't hear. Why can I not hear?
Literally, I don't know why.
That is right in my ear. Shut up. Shut
I
up.
apologize.
Everybody wants me to write you up. Everybody in this class. Yes. Only one of the numbers needs to be on the list. That's exactly right. You want the biggest one from that list too. All right, so, and I chose that because now 3 goes on the outside. I've still got the 4 under there, and now I'll worry with these variables. 3 goes into 13 how many times? 4. How many's left? 1. And then 3 goes into 6 how many times? 2. How many's left?